The topic we'll discuss today is real numbers. Since the day one of our school age, we learned about numbers, the number system, various types of numbers. The same number system will repeat here. Number system is the one of the fundamental topic. There is a lot of chance to be questions will be asked in various competitive exams like APPSC, UPSC, banking, RRB, and other government exams. Before going into the lesson, if anyone new to this channel, please subscribe the channel. In channel description, we have community links for the Telegram, community link for the WhatsApp, as well as Instagram. Please follow them also. Real number. What are real numbers? Simply, by the definition, the real numbers are all the numbers that can be represented on the number line. This is the number line. In this number line, we have some numbers, some positive numbers. We have right side positive numbers, left side negative numbers. In the middle, we have the 0. So, it's nothing but it's a neutral number. So, observe here the number -4, -3, 2, 1, 1, 2, 3, 4, 5 and so on. All the numbers are represented on the number line. So, I can call it them as a real numbers. Not only the numbers which are visible to here, other numbers also can be represented on number line. Let's say for example, see here 1.5. Where is 1.5 located on number line? In between the 1 and 2. So, this is the point 1.5. This is also the real number. So, in this manner, all the possible numbers which are represented, which can be represented or which are represented, which can be represented, we can call it as a real numbers. Again, these real numbers are two types, rational numbers, irrational numbers. Go through one by one. The numbers which are used to count any quantity, we can call it as a natural numbers. Let's say the example for the natural number is 1, 2, 3, 4 and so on. Whole numbers. What is whole number? Whole number is if 0 is added to the natural number, then it will become whole number. See here, the whole numbers are 0, 1, 2, 3, 4 and so on. Which means we are adding in the whole number, we are just adding 0 to the natural numbers. See here 1, 2, 3, 4 and so on is the natural number. So 1, 2, 3, 4 so on is the natural number. We are just adding 0 to the 1, 2, 3, 4. Which means that we are adding 0 to the natural numbers, then it will become whole numbers. Then come to what is integer. What is integer? Simply the integer is a group of number which includes negative numbers, 0 as well as positive numbers. Natural numbers, whole numbers as well as. See here 0, 1, 2, 3, 4 and so on is a whole number. Okay. 1, 2, 3, 4 and so on is the natural number. In the integers, natural numbers also included. In the integers, whole numbers also included. In the integers, negative numbers also included, positive numbers also included, 0 also included. So, I can say all the natural numbers are whole numbers. Why? Because all the natural numbers can be included in whole numbers. Okay. All the whole numbers are integers. Why? Because all the whole numbers are included in the integers. So, all the natural numbers are integers, all the whole numbers are integers. Rational number. What is rational number? Simply any number which can be represented as a P by Q form. See here, P by Q form. Any number which can be represented as a P by Q form, we can call it as a rational number. See here, 1 by 3, 0 by 1, -2 by 5, 4 by 1. So, all these numbers are represented in P by Y Q form. So, I can call these numbers as a rational numbers. Next, prime numbers. What is prime number? A prime number is any number which is divisible by itself and 1. Then only I can call it as a prime number. Let's say, for example, consider 2. 2 can be divisible by 2 itself as well as 2 can be divisible by 1 only. So, it can be divisible by itself and it can be divisible by 1. So, there is no divisible numbers which can divide the 2. So, I can say 2 is the prime numbers. 3 also prime number. Why? Because 3 can be divisible by itself as well as it can be divisible by 1. Except 1 and 3, there is no number which can divide number 3. So, I can call it as prime number. See, take 5. 5 can be divisible by 1 as well as 5 can be divisible by itself. So, there is no other number which can divide the 5. So, I can call it as a prime number. Note here, 2 is the only even prime number. Except 2, all the even numbers are not the prime numbers except 2. Composite number. What is composite number? Composite number is any natural number greater than 1 that has more than 2 factors. What's the difference between the prime number and the composite number? Simply, in the prime number, that particular prime number has only 2 factors, either itself or 1. Only 2 factors. But in the case of composite number, it has more than 2 factors. Let's say, for example, 4. 4 can be divisible by 1 also. 4 can be divisible by 2 also. 4 can be divisible by itself 4 also. So, 1, 2, 4. Total 3 factors we have. So, this is more than 2. So, I can call 4 as a composite number. So, in this manner, any number which has more than 2 factors, I can call it as a composite number. See, note a point here. 1 is neither prime number nor a composite number. So, we have gone through all the rational numbers and their types with their definition and with examples. Then coming to the irrational numbers. What are the irrational numbers? Simply, the numbers which are not expressed in the form of rational number, or the numbers which are not expressed in the form of p by q, I can call it as an irrational number. So, irrational number cannot be written as a fraction. Fraction in the sense p by q. Any number which cannot be written as a p by q form, I can call it as a irrational number. So, these irrational numbers are non-terminating as well as non-repeating decimals. For example, square root 2, pi, e, root 3 are the examples of the irrational numbers. Why? Because let's say, for example, consider pi. What is the value of pi here? If we calculate the value of pi in the form of decimal numbers, it will be 3.14159265 and so on. Which means after 3.1415, so many numbers are coming, but they are not repeating. So the sequence is not repeating. We don't know which will be the end number. So after 3.1415, so many numbers going on. There is no end to the number. So we can say this is the irrational number. Why? Because we cannot express that particular number in the rational form. So I can say it's an irrational number. As well as root 2 also. The value of root 2 is 1.41421356 and so on. So after the decimal, numbers are going on. We can't say which is the end to the decimal number. So I can say root 2 also is an irrational number, as well as root 3 also irrational number. So in this man, we have to check whether it is a rational number or irrational number. The fundamental theorem of arithmetic. What is the fundamental theorem of arithmetic? Simply, every composite number can be expressed as the product of primes. And this factorization is a unique method. Let's say, for example, 24 is the composite number. Why? Because 24 has more than 2 factors. So I can call 24 as a composite number. This 24 number can be expressed as the multiples of prime number. See here, 24 can be expressed as the factors 2 into 2 into 2 into 3. See here, all the numbers included are prime numbers. So the 24 can be expressed as the product of these prime numbers. So the same thing has been explained in the fundamental theorem of the arithmetic. Simply, the fundamental theorem of arithmetic is any composite number can be expressed as the product of the prime numbers. Here 24 is a composite number. It is expressed as prime number. The product of prime numbers 2 into 2 into 2 into 3 is a prime number. So the 24 composite number expressed as a product of these prime numbers. Here also 30 composite number is expressed as these prime numbers 2 into 3 into 5. Why? Because 2 is a prime number, 3 is a prime number, 5 also a prime number, which means every composite number can be expressed as the product of the prime numbers. LCM versus HCF and their applications. So what is LCM and what is the HCF and their application in the practical life? Simply, the LCM is the least common multiplier. So LCM of 2 or more numbers is smallest number that is multiple of all the given numbers. Say here, for example, what is the LCM of 4 and 5? Simply, we need to find the multiples of 4 and the multiples of 5. Let's say multiples of 4 equal to, simply we need to write the 4 table. 4 2 is 8, 4 3 is 12, 4 4 is 16, 4 5 is 20, 4 6 is 24 and so on. So just multiple of 4 means we need to write the 4 table. In the same manner, the multiples of 5 means we need to write 5 table. Okay. After writing the multiples of 4 and the multiples of 5, we need to compare these multiples. First, what is common here? So 20 is the common number. So the common number between the multiples of 4 and the multiples of 5 is the 20. So 20 is the common number in the multiples of 4 and in the multiples of 5. So I can say 20 is the LCM of 4 and 5. Now you got to know the what is the actual meaning of the LCM of two numbers. Okay. What's HCF? Simply HCF is the highest common factor. Highest common factor. HCF is the largest number that can exactly divide all the given numbers. Now, highest number that can exactly divide all the numbers. Let us take an example here. HCF of the 18 and 24. Simply, we need to find the factors of the 18 as well as we need to find the factors of the 24. See here, at factors of the 18 equal to 1 into 18, 2 into 9, 3 into 6. All this product equal to 18 itself. So I can say 1, 2, 3, 9, 18, 6. See here, 1, 2, 3, 9, 18, 6 are the factors of 18. In the same manner, the factors of 24 equal to all these numbers are factors of the 24. So I am noting here all the factors of 24. Need to compare these two factors. See here, this is the factors of 18. These are the factors of 24. So what is the common factor both of them? Highest common factor. See here, 1 is a common factor, 2 also a common factor, 3 also a common factor. Okay, but 6 also a common factor. Which is the highest common factor? In this common factor, 6 is the highest number. So I can call it as a highest common factor. Simply, to find out the highest common factor, we need to write the factors of the any two numbers which is asked. After that, we need to compare both factors. We need to find out the common factor which is the highest number. In this given example, comparing these two factors, I got number 6 as the highest common factor. So I can say this is the HCF. There is another method to find out the LCM and HCF, that is prime factorization method. Simply here also we need to find the factors of the given numbers. So we go through the example problem. Find the LCM and HCF of 6 and 20 by the prime factorization method. The first step we have to follow, find the factors. The second step is compare the factors. Let's go through the first step. What are the factors of 6? Simply 6 equal to 2 into 3. This is the factors of 6. Then coming to the 20. What is the factors of 20? Simply factors of 20 is equal to 2 into 2 into 5, which is nothing but 2 square into 5. So these are the factors of the 6 and factors of the 20. So I completed the step 1. Then come to the step 2. In step 2, we need to compare the factors. 2 into 3 and 2 square into 5. So these all are the factors, both factors. So I am just note down the factors of 6 as well as factors of the 20. Generally, LCM is the product of greatest power of the each prime factor. To find the LCM, simply we need to write the factors. Simply what are the factors here? We need to write all the factors. 2, 3, 5 are all the factors. Just first write down the 2, 3, 5. Okay. In the LCM, we need to find highest powered factor. So here the highest powered factor is 2 square. So I choose 2 square here. I am not choose 2 power 1. Why? Because I need to choose highest powered factor. So I choose 2 square. So by multiplying 2 square into 3 into 5, I got 60 as the LCM. As well as for the HCF also, we need to follow some steps. It's simply HCF is the product of smallest power of each common prime factor. Compare these factors. Least common factor. What's the common factor here? Here 2, here 2 power 1, here 2 square. So 2 is the common factor for the number 6 and number 20. In these two common factors, we need to consider only the least powered common factor as per the definition. Why? Because HCF is the product of smallest power of each common prime factor. So I consider 2 power 1. So it will become 2. So my HCF became 2, my LCM became 60. In this manner, we need to find out the LCM and HCF by prime factorization method. For any two positive integers A and B, HCF of AB into LCM of AB will become A into B. Note, it's applicable for two numbers only. Example number 4. Find the HCF and LCM of 6, 72 and 120 using the prime factorization. Here also, simply we need to follow two steps. The first step is we need to write the factors. See, the factors of 6 equal to 2 into 3. The factors of 72 equal to 2 into 2, 2 into 3 into 3 into 3, which is nothing but 2 cubed into 3 square. The factors of 120 equal to 2 cubed into 3 into 5. So these all are the factors. These all are the factors of the given numbers. Now, by using these factors, we need to find the LCM and HCF. Simply, first we need to find the LCM. Simply, LCM is the product of all the factors. See here, 2, 3, 5. See, 2, 3, 5 are the common factors. So, I wrote down here first 2, 3, 5. As per the definition, we need to consider the highest powered prime numbers. So, in this comparison of factors, I have 2 cube is the highest. So, I choose 2 cube here. Later, in the factor 3, 3 square is the highest factor. So, I choose 3 square here. For the factor 5, I have only highest power, that is 5 power 1. So, I choose 5 power 1. By simplifying, we will get 360 as the LCM. What is HCF? Simply, as per the definition, HCF is the least powered common factor. What is the common factor here? 2 is the common factor. We need to find the factor which has least power. Here, 2 power n is the least powered factor. So, I chose it 2 power 1, and another common factor is 3. So, the least power is, this is also 1. So, 3 power 1. So, total power 1 into 3 power 1, it will become 6. Point number 7. Square root of p is irrational if and only if p is the prime number. If p is the prime number, then square root of p will become irrational number. Let's say square root of 2 will become irrational. Why? Because 2 is a prime number. Square root of 3 also a irrational number. Why? Because 3 also a prime number. Square root of 5 also square root of 5. This is also irrational number. Why? Because 5 is a prime number. Next question. Sonia will take 18 minutes to complete a round, and Ravi take 12 minutes to complete a round. If they both start at the same point at the same time, if go in the same direction, after how many minutes will they meet again at the starting point? This is a ground. Sonia take 18 minutes to complete a round, as well as Ravi take 12 minutes to complete a round. To complete a round, he will take 12 minutes. If both of them start at one point, at same time, at same place, then after how many minutes they can meet at particular point? So that's the question. To solve this kind of questions, always use the LCM. Simply, we need to take the LCM of 18 and 12. The factors of 18 equal to 2 into 3 square. The factors of 12 equal to 2 square into 3. Simply, the LCM is the product of highest powers. We know that highest power 2 is 2 square. Highest power 3 is 3 square. So, it will become simply 2 square into 3 square, which is nothing but 36 minutes. See question number 9. Another method of finding HCF and LCM. Simply, I will give you an example. Find the LCM of 2 and 2, 8, 14. To find out the LCM of 2, 8, 14, first note down 2, 8, 14, L-shaped line here. Start with least prime number. See, 2 is the least prime number. So, I am starting with 2. 2 1s are 2, 2 4s are 8, 2 7s are 14. Okay. After that, we need to multiply all these numbers. 2 into 1 into 4 into 7. 2 into 1 into 4 into 7 will become 56. So, 56 is the LCM of the 2, 8 and 14. As well as another method for the finding the HCF of 8 and 18. Simply, we need to divide large number with small number. So, here the small number is 8, large number is 18. So, I am dividing the 18 with 8. So, by dividing, I will got 8 2 is 16. The remainder will become 2. Again, this number will become dividend for me. So, the remainder will become divisor. So, 2 into 4, 8. I got the remainder 0. So, to continue this process until we get the remainder 0. So, where we get the remainder 0, then its divider will become HCF of the particular number. Now, here the HCF of 8 and 18 equal to 2. If any two numbers have their HCF as 1, then we can say they are co-prime numbers. So this is all about the real numbers. One of the easiest chapter as well as most important in the field of competitive examinations. In the next class, we'll get various questions from the number system from various competitive examination we'll discuss, as well as academic questions also discussed. If anyone new to this channel, please subscribe the channels. If anyone have the doubt, if anyone want to give the feedback, please comment in the comment section.